Hello, guys. Assalamu alaikum, everyone. I'm Vaniza. I'm a first year medical student at the Al Khan University. And today I'll be going through some questions related to science reasoning. So, is it okay if I start now? Okay, so the first passage is based on X ray distortion and planet detection. Astronomers propose that the release of high energy gamma rays by distant stars and the degree of deviation or bending of these rays may signal the presence of orbiting celestial bodies. So, this basically means that high energy gamma rays are being deviated, and this deviation shows the presence of orbiting celestial bodies. As the gamma rays travel through space, they can be deflected due to the gravitational influence of planets orbiting these stars. So, this tells us that it is the gravitational influence of these orbiting celestial bodies that is causing gamma ray deviation. So, gravitational influence is the main thing over here. The magnitude and the pattern of bending are important indicators. A high degree of bending suggests the presence of massive planets, so a high degree suggests massive planets. While a low or no bending is likely associated with small planets or no planets at all. So, low or no bending. So, here we can see that low bending is associated with small planets, while no bending is with no planets at all. Additionally, the pattern of bending over time helps to determine the type of an orbit. A regular pattern may indicate a circular or elliptical orbit, while a random pattern may indicate no planets or interference from non-orbital sources. So basically, regular pattern here is indicating our circular or elliptical orbit. That is the main part in this paragraph. And then while a random pattern will indicate no planets or interference from non-orbital sources, which are not our concern for this question. So figure one, which is on the next page, depicts a star system with gamma rays being bent by nearby orbiting bodies. Table 1 shows the bending of gamma rays observed over 4 consecutive days for 4 different stars, that is Zeta, Orion, Lyra, and Helix. So now this is the table that was mentioned in the earlier thing. So there are 4 stars, Zeta, Orion, Lyra, and Helix, on 4 different days. So we'll first analyze the table and then move on to the questions. So when we see the first star, we can see that on day 1, the bending is 1 meters, then 1.75 on day 2, 2.5 on day 3, and then 3.25 on day 4. So we can easily see that there is a difference of 0.75 meters on each day, right? And this indicates a regular pattern. As we saw earlier, that it said that, as I can go over here, it said that a regular pattern indicates a circular or an elliptical orbit. So this can be seen with Zeta over here. The second is Orion, where there is no bending at all, which is shown by 0.00 on all 4 days. That shows that there is no planet at all, as we had already studied earlier. And then for Lyra, we can see that on day 1, there is a huge bending of 8 meters. This shows the presence of a big planet for Lyra. And on each subsequent days is a pattern for Lyra. That is, for on day 1 it is 8, on day 2 it is 4. So we can see it is being divided by 2 on each day. And then day 4 divided by 2 is 2 meters, and then we can see 1 meters, which is again divided by 2. Whereas for helix, we can see that on day 1 it is 0.2 meters, and then it increases by 0.9 meters to form 1.1, and then it decreases again by 0.89 meters with 0.9 0.11 and then it stays constant. So over here we can see there is no regular pattern, no pattern at all. So after this, we will now come to the questions. The first question is, which of the following statements is best supported by the passage? So the first option is A. Lyra is likely orbited by at least one massive planet, which is correct, as we mentioned earlier in the table that on day one the bending is 8 meters, which is a huge amount of bending. And in the paragraph earlier we had studied, as we can see that a very high degree of bending suggests the presence of massive planets, so first option is correct. For B, helix has a circular orbit. Over here we can, as I mentioned earlier, in helix there is no regular pattern. That means there is no circular or elliptical orbit in this, so this will be wrong. While for C, Orion is likely orbited by several small planets. We can see in the table that there is no change in Orion, like the bending is 0 on each of the 4 days. That means there is no planet at all. So this will be wrong also. And for D, Zeta has no planets orbiting it, which is false because it is a regular pattern. We can see in Zeta it is a regular as well as a repeating pattern, as well as an increasing pattern. So there are likely to be planets that are orbiting it. So D is wrong. If there's any confusion in this question, you guys can text in the chat. Okay, we'll now move on question number 2. If the gamma ray bending from zeta continues at the same rate, what would be the expected distortion on day 7? So we know that distortion is the degree of gamma ray bending. We know that for zeta, it is 0.75 on each of the 4 days. The difference is 0.75. So 3.25 we can see is on day 4. So, and we need to calculate for day 7. So we will now move to day 5, day 6, and day 7. That means we need to add 0.75 three times. That is 0.75 multiplied by 3. This will give us, I'll calculate side by side. This will give us 2.25, and then we will add this to 3.25. Which gives us an answer of 5.5. And we can see that 5.5 is in option number C. So if there's any confusion in this part also, please do message. Okay, so we'll move to question number 3 now. Which of the following assumptions is most supported by the passage? Part A is gamma rays are too energetic to be influenced by gravitational forces. This is absolutely wrong because the whole question is dependent upon gamma ray bending because of gravitational forces. If gamma rays were not bending because of gravitational forces, we wouldn't have gotten any of the values that we can see in the table. So this is wrong. Part B is all planets orbit in circular paths. This is also wrong because we can only see that two planets, like that is Zeta and Lyra, have a regular and repeating pattern. So they could be orbiting in a circular or elliptical path, these two. While Orion has no planets, so there is no circular path, and Helix is irregular, that is no pattern at all. So in this way, B is also wrong. C is the gravitational pull of the planets can alter the path of high energy rays, which is correct, as we saw, as I explained in part A, that gravitational pull of the planets is altering the gamma rays. And part D is a star with no distortion always has an elliptical orbit, which is wrong because The question mentioned that a star with no distortion indicates no planets. Like no bending indicates no planets at all. So this is wrong. The last part is which of the following stars most likely has at least one planet with an elliptical orbit? So the first option is Orion, which is wrong because it has no planet at all. Part B is Helix, that has no pattern, so no planet. Part C is Zeta and Lyra. Zeta and Lyra did have a regular repeating pattern as we saw over here, so this is correct. And D is Zeta, Lyra, and Helix. Helix had no pattern, so this is the odd one out of the three, which makes this option incorrect. So guys, if you have any problem in this question or any problem in the whole passage, do let me know. So now we will be moving on to the next question. So this passage is related to bacterial growth. Bacteria are classified by their response to temperature. The categories include psychrophiles, psychrotrophs, mesophiles, and thermophiles. So the first table is based on their growth ranges. Like psychrophile has a minimum of less than 0, an optimum between 0 and 10, and a maximum of less than 20. The second is psychrotroph that has a minimum of 0 to 5 degrees, optimum of 15, and maximum of 30. While mesophile has a minimum of 5 to 25 degrees, optimum of 18 to 45, and maximum of 30 to 50. And thermophile has a minimum of 25 to 45 degrees Celsius, optimum of 50 to 60 degrees Celsius, and a maximum of 60 to 90 degrees Celsius. So basically over here, the minimum, optimum, and maximum, what do they actually mean? Minimum means that it is the minimum temperature at which this type of bacteria will work. And like below this temperature it will not work at all, because as we know that bacteria also has enzymes, and those enzymes need temperature to work. So if it is below this temperature, these enzymes will be inactive. For optimum means the higher the it basically means the like what can I say, it's the best temperature for for the enzymes within the bacteria to work. The enzymes at this temperature will have their highest activity, while maximum temperature is the most amount of temperature at which a bacteria can work. And if we exceed the temperature, the enzymes that are present within the bacteria will actually denature. So this is the significance of all the three temperatures, categories of temperatures that are there. So now we have another table, which is the cardinal growth point. Basically, this table has a list of bacteria that are under those four categories that we already studied, that is psychrophile, psychrotroph, mesophile, and thermophile. So these are the minimum, optimum, and maximum temperatures of all these three bacteria, and now we're going to classify them according to these four categories before moving on to the question. So the first bacteria has a minimum of 30, optimum of 60, and a maximum of 72. So this easily fits into the thermophile category. I have attached a table above for reference, because we can see minimum falls in the 25 to 45 range, optimum, that is 60, falls in the 50 to 60 range, and 72 falls in the maximum range, that is 60 to 90. And we can see for all the other three, the bacteria doesn't fall in any of these ranges. The second one has a minimum of 30, optimum of 60, maximum of 72. That is the same as the first one, so this is also a thermophile. The third one has a minimum of 15, which fits in the mesophile category, as we can see. Optimum of 45, that is also fitting into the mesophile category, and a maximum of 50, that is also fitting into this category. So this will be a mesophile. E. coli, we can see, has a minimum of 10, that fits again in the mesophile category, optimum of 37, which is fitting in this again, and a maximum of 45. This makes it another mesophile. The fifth bacteria has a minimum temperature of 1 degree Celsius, which fits in the psychotroph category. Optimum of 34, which fits into the mesophile category, and a maximum of 45, that is again fitting into the mesophile category. This one was the psychotroph. These two were mesophiles. So this shows that the bacteria is of both categories, psychotroph as well as mesophile. Because of the minimum temperature of 1 degree Celsius, that will fall in the psychotroph category. So for the sixth bacteria, it has a minimum of 0, that falls in the psychotroph category, optimum of 15, that is again falling into the same category, and a maximum of 30, which again falls into the same category. So this one is also psychotroph. Then the seventh bacteria has a minimum of 10, an optimum of 37, and a maximum of 45. 10 minimum falls in mesophile, same as with the optimum and maximum, so this is again a mesophile. For the eighth bacteria, it has a minimum of 25, optimum of 37, and a maximum of 42, that again fits into the mesophile category. And for the last bacteria, 25, 37, 40, again mesophile category. So by this we can see that there are a lot of bacteria that actually fit into the mesophile category. So along with this, we'll also calculate the range of these bacteria. So the first bacteria has a range of, I'll just indicate over here, 42 degrees Celsius. The second one has the same range of 42. The third one has a range of about 35. The fourth one has a range of 35 again. The fifth one has a range of 44. And I didn't mention earlier, but the range is calculated by max minus min. This is the formula of range. Do remember this, it is very important. And for the sixth bacteria, the range is 30. For the seventh bacteria, the range is 35. For the eighth bacteria, the range is 17. And for the ninth bacteria, the range is 15. So what I did for all of them was, over here I did 70. For the first bacteria, I did 72 minus 30. So this gave me this answer. For this also I did the same, 72 minus 30. So this gave me this answer. And I did the same for all the rest of the bacteria with the formula max minus min. So if we analyze the ranges of all these bacteria, we can see that Streptococcus pneumonia has the least range of 15 degrees Celsius. That is the least range. If you guys have any problem with this, do let me know in the chat. Okay, so we will now be moving to the worksheet. So the first question is the category of bacteria appearing the most frequently in table 2 is a mesophile, that is option C. We already did it earlier that mesophile was the most the mesophile was the category of bacteria that was the most prominent in the list of bacteria that we were given. Like we can see mesophile is 1, 2, 3, 4, 5, 6. It's coming 6 times out of the eight bacterias. So it is the one that is the most dominant one over here. And then there's the other question, that is question 6. The type of bacteria found in table 2 that does not fit exactly into any of the categories listed in table 1 is. So the first option is Clostridium perfringens. We will check this over here. Clostridium perfringens clearly fits into the mesophile category because we can see that the minimum temperature is 15 degrees Celsius, that perfectly fits. Optimum is 45, that is fitting again. And the maximum is 50 degrees Celsius, which also fits into the mesophile category. And it also has a big range. There is no problem of range over here also, because bacteria with small ranges don't usually fit into the categories. But this one has a broad range, so we can easily agree that this option easily fits, so this is wrong. The second one is Listeria. So we'll check this again. Listeria belongs to both categories. It belongs to mesophile as well as psychotroph category, as we already mentioned earlier. So this might seem as the answer, but it is not the answer, because there are some types of bacteria that are present which have two categories. So this one option is also incorrect. The option C is Micrococcus cryophilus. We'll check this again. This one has a minimum of 0 degrees Celsius, optimum of 15, and maximum of 30, which is clearly fitting in the psychotroph category, and it has a broad range of 30 also. And as we can see in the table also has a range of about 30. Like the minimum to the maximum range is 30. So this one is clearly fitting into this category, and there is nothing wrong with this type of bacteria. So Micrococcus cryophilus is also incorrect. So the last one is Streptococcus pneumonia, which is the answer in this case, and I will explain you why. We already mentioned that Streptococcus pneumonia was in the mesophile category. But we can see that mesophile, which typically has a minimum of 5 to 25 degrees Celsius, and the problem over here is that it lies in the upper range of the mesophile category. Like 5 to 25 was the minimum one, and it lies in the upper range of minimum, that is 25 degrees Celsius. Along with that, we can see the optimum is okay. There is nothing wrong with this. Even but the max is slightly lower as compared to the mesophile category, because we can see that each of the others have a greater maximum, that we can see, like for the streptococcus pyogenes, it has a maximum of 42 degrees Celsius. Staphylococcus aureus also has a maximum of 45, which is all greater than 40. Even Listeria has a maximum of 45, again E. coli 45, and then Clostridium has 50. So we can see that even the max is low for this case. The max is low. And another thing that we should consider is that the range is very less in this case. 15 degrees is the smallest range among all of these three, which clearly shows that it is not clearly fitting into the mesophile category. So, and not in any other category, as we can see that we already did it earlier when we were doing this, that it is not fitting into any other category. So Streptococcus pneumonia, out of the three bacteria that I mentioned, will not fit into the category. So if there are any questions regarding this, please feel free to ask. Basically, in this question, number six, we just did like choose the best answer. Because among all A, B, and C, they were clearly fitting into their own categories. So D was the one that was slightly off, which was not fitting directly into the category. That's why this is the answer. So we are basically comparing all the three options over here. Okay, so now we'll move to question number seven. Average human body temperature is 40 degrees Celsius. According to table 2, which of the following bacteria would grow most successfully in the human body? The first one is Anoxybacillus flavithermus. So we'll check the optimum temperature of this one, because as it is mentioned, the average human body temperature is 40 degrees Celsius. So we need to see which one will grow most successfully. So when we're talking about which one will grow most successfully or more prominently, we need to see the optimum temperature in this case. Because as optimum temperature in this case, because optimum temperature, because we know that a bacteria will actually thrive in its optimum temperature. It will not thrive in its minimum temperature or its maximum temperature, because maximum temperature can even go overboard and it can cause the bacterial enzymes to denature, while for minimum the enzymes might still be too inactive to work. Like some of the enzymes might start working and some of the enzymes might not work. But at the optimum temperature, all of the enzymes are working at their best capacity. So we'll check option A first. This one has an optimum of 60 degrees Celsius when we are concerned about 40. So it is not fitting into the category. That means option A is incorrect. Now we're talking about option B, that is Clostridium perfringens. Clostridium perfringens have an optimum of 45 and we're talking about 40 degrees Celsius. This shows that the optimum is way above as compared to what a human body's optimum is. So this means that it can't fit into the category because some of the enzymes will still be inactive at human body temperature. So B is incorrect. C is E. coli. So E. coli has an optimum of 37 degrees Celsius. So this is very close to 40 degrees Celsius, and it can actually fit into this category because if the optimum is at 37 degrees Celsius and the maximum is at 45 degrees Celsius, as we can see, 45. So that means, first of all, the enzymes will not, that means the enzymes will not denature, the bacterial enzymes will not denature, and secondly, all the enzymes will be working at their optimum temperature, because optimum was 37 and now the optimum temperature of the human body is 40. That means all of the enzymes have been active before that temperature alone. So E. coli is quite fitting into this category. We'll just Consider this as an option and first see if the last one is more suitable for this category or not. So D is Listeria. We'll check this in the table. For Listeria, the optimum is 34 degrees Celsius and the maximum is 45. Since the optimum is quite low than 40, it's like it's very considering E. coli, it is very low than 40. So there might be a chance that some enzymes might not work at their optimum level because they are way above their optimum temperature. So if we compare for E. coli, we compare for E. coli as well as for Listeria, we can clearly see that the enzymes of E. coli will work at a better rate as compared to Listeria because Listeria's optimum was quite lower than 40, while for E. coli it was slightly closer to 40, so enzymes will be better suited for the human body temperature when we are talking about E. coli. So here we can clearly see that E. coli will be the answer. If there are any questions regarding this, please mention in the chat. Okay, so now we're moving to question number 8. A new bacteria was discovered. It reproduces best at 55 degrees Celsius. Reproduces best again means optimum temperature. And does not show any new growth if exposed to temperatures above 65. Why won't it show any growth? Because above 65 enzymes will denature. So this bacteria can most likely be categorized as, we can see optimum is 55 and the maximum temperature is 65. So now we need to fit in to those four categories that we saw earlier. So when we are looking at these four categories, we can see easily that the optimum of 55 only fits into this thermophile category. And the max of 60 to 90, we had the max of 65 in the question that only fits into the max category of thermophile. So the answer of this question is thermophile again, because if we compare it to all the others, psychrophile, psychrotroph, mesophile, optimum is way higher. 55 optimum is way higher than the range, and even the max range is way higher for the way higher, like 65 is way higher than the maximum range. So the answer should be thermophile over here. If there are any problems with this question, feel free to ask. Okay, so moving on to the last question. Question 9. Based on the information in table 2, which bacteria has the smallest growth range? We already calculated the growth ranges in the table previously. So we'll now just list the growth ranges of all the four bacteria that are present in these options and compare which one has the smallest. So first we'll start with Listeria and Micrococcus. So Listeria has a growth range of about 44 and Micrococcus has 30. So we'll mention over here that is 44 and 30. And now there's the remaining two, Streptococcus pneumonia and Streptococcus pyogenes. So Streptococcus pneumonia has 15. That was the smallest strain. That was like the smallest strain that we had already calculated before. And Streptococcus pyogenes has 17. So we'll write over here 15 and 17. So over here it is clearly visible that Streptococcus pneumonia has the smallest growth range. So option C is the answer. If you guys have any questions regarding this, feel free to ask. So basically, this is the end of the science reasoning demo class. If you guys have any questions related to science reasoning, like how to, like what resources to use for it when preparing for the AQ test, or any questions regarding the AQ test, do message in the chat and I'll answer them. Or any questions regarding the two questions that I solved right now.